Chemistry is a branch of science which deals with different properties of different substances. Now the question arises, what is matter? So matter is anything which has mass and occupied space. A table, a chair, even a small pen is a form of matter. Elements. What are elements? Elements are the substances which can't be further divided. For example, we have metal, non-metals and metalloids. Our very renowned scientist has discovered many periodic tables to study the properties of different elements. But out of those all, we have the best one, that is modern periodic table. We also called it long form periodic table. Modern periodic table is based upon atomic number, or we can also say on the basis of electronic configuration. It is divided into 7 periods and 18 groups. This periodic table is further divided into 4 subgroups: S block elements, P block elements, D block elements and F block elements. S block elements and P block elements combinedly known as main group elements. The D block elements are known as transition elements and the F block elements are known as inner transition elements. S block elements are also known as metals. P block elements contains metals, metalloids and also non-metals. D block elements contains only metals and F block elements contains matter as well as radioactive elements. Before going into the properties of periodic table, let's first discuss about the structure of atom. Atom consists of the nucleus at the center and outermost shell around it. Our nucleus contains positively charged proton and neutrally charged neutron. Outermost shells contain negatively charged electron which revolves around the nucleus. That is the structure of atom. Now let's talk about the first property of our periodic table, that is atomic radius. Atomic radius is the distance between the nucleus and the outermost shell of the atom. Now let's talk about the trend of atomic radius in the periodic table. So atomic radius increases down the group and it decreases along the period. Let's take an example of our first group, that is alkali metals. So we have hydrogen, lithium, sodium, potassium, rubidium, cesium and francium. When we move down the group, the atomic number increases. So due to increase in atomic number, the outermost shells increases too. As the number of outermost shells increases, the distance between the nucleus and the last outermost shell increases. So that is why the atomic radius of sodium is greater than the atomic radii of lithium. Now let's talk about the trend along the period. When we are moving from lithium to beryllium in area, we can see that the electronic configuration of lithium is 1s2, 2s1 and beryllium 1s2, 2s2. In this case, in beryllium case, we have full filled S. Let's take an example of sodium metal and magnesium. If we look at the electronic configuration of sodium, that is 1s2, 2s2, 2p6 and 3s1. And if we are talking about the electronic configuration of magnesium, that is 1s2, 2s2, 2p6, 3s2. As you can see, there is 3s1 and here it is 3s2. Now, there is increase in the number of electron, but that electron is added into the same shell. So it means we can say that, as we all know, atomic number is equal to number of proton which is equal to number of electron. Means atomic number will be number of electron is equal to number of proton. Now let's discuss the trend followed by ionization enthalpy in the modern periodic table. Firstly, we will discuss the trend along the period. So along the period, ionization enthalpy increases. Why it increases along the period? So let's talk about it. Let's take an example of lithium and beryllium. So lithium has electronic configuration 1s2, 2s1, and beryllium has electronic configuration 1s2, 2s2. As we can see, there is increase in atomic number as well as increase in number of electrons and number of protons. Due to that, force of attraction between the nucleus and this outermost shell has been increased. Due to that, if we want to remove the outer electron from this shell, it is difficult for us to remove that. So we need high amount of energy to remove an electron from the isolated gaseous atom. So that is why ionization enthalpy required to remove an electron from the beryllium is much more than the lithium. Now let's talk about the trend followed by ionization enthalpy down the group. Down the group, the atomic number increases, so the number of shells. Now just imagine, there are two students, first one is first bencher and the other one is last bencher. So the interaction between the first bencher and the teacher will be more as compared to the last bencher and the teacher, because little noise will be sufficient to distract that last or back bencher. So that is the similar case in case of atoms. As we move down the group, the atomic number increases, so the number of shells. So the distance between the nucleus and the outermost shell increases. So just imagine the force of attraction between the nucleus and this first shell will become more powerful as compared to the force of attraction between the nucleus and the last subshell or shell. So to remove that electron, we need sufficient amount of ionization enthalpy. Means we can also say that we need a little amount of ionization enthalpy to remove the electron. So that is why down the group, ionization enthalpy always increases, and along the period, ionization enthalpy always decreases. Now we will talk about the third property, that is metallic character. So I have already discussed about the four different groups which are the part of periodic table, that is S block elements, P block elements, D block elements and F block elements. I have already shared that the S block elements contains metals, and as you go along the period, the metallic character will decreases as P block elements contains metals, metalloids and non-metals. So let's talk about the third property, that is metallic character. So down the group, if we are talking about down the group, the metallic character increases down the group. As we move along the period, what happens? The atomic number increases, but the electron is added to the same shell. And due to that, there is a high force of attraction between the nucleus and the outermost shell. And as a result, it is difficult to remove an electron, as we have already discussed in case of atomic radius and ionization enthalpy.